My name is Tamás Balog. I've been working for Axis for 5 years now in the developer team, and today I would like to show you one of our new features, namely the imp module. This module can be used to create imperfect geometry of structures from backlink mode shape or several backlink mode shapes. I will give you an introduction and overview about the module in a presentation. As you can see here in the first section, I introduce you to the problem. Secondly, I will give you an introduction to the use of the module. And in the third part, I would like to show you an example. In this presentation, I will focus on the design of steel structures, but what I am going to tell is true and can be used as well in case of different kind of materials, but mainly for or in case of metal buildings and metal structures. As I mentioned earlier, the imp module can be used to create imperfect geometry from backlink mode shapes by scaling and superposing these shapes. This is very useful, for example, in steel design, because we live in an imperfect world. According to this fact, we need to consider several kinds of imperfections in the design, coming from, for example, residual stresses, imperfect geometry, or eccentricities in loading or boundary conditions. According to the design codes, we have to assume global and local imperfections that may be derived many times from the elastic backlink mode of the structure. This is this is where our new module can help you to create these global and local imperfections can be used in nonlinear, static, and dynamic analysis. Another important aspect is that modern design codes can allow the finite element method-based design, which means that stability verification, or for example, steel structures can be performed as strength verification using a geometrically nonlinear analysis, considering equivalent geometrical imperfections. This is an advanced level, an advanced use of this module, but it is a possibility. There are other aspects which make this new module this new feature very useful and important. We will able to create imperfection shapes for different kind of structures without any restriction of the form or shape of the structure. We can use this new module by stability verification, for example, in case of complex geometry, loading conditions, or boundary conditions. If you check the picture on the right, you can see a very complex steel joint, which that can be rarely verified with simple models from the codes. And if you have this problem or design problem in the real life, you can use more advanced methods. For example, finite element based design to get based on our new imp module and nonlinear materials as well. If you have a very complex problem, the given formulae in design codes may be used only for certain cross sections or geometrical loading conditions that can result that the guidelines in the code may not valid for your case. In your case, there are other problems if the standard conforming verification method is too complex, as you can see in the case of effective cross-section calculation of plated steel element. According to the possible applications, I collected some on this slide. First of all, I mention again the generation of imperfect geometry, and not only, it's very important that not only global imperfections, but we can also create local imperfections and assign to the model. These imperfections, these geometry after can be used in a geometrically nonlinear static or dynamic simulation. In case of finite element based design, we have to mention that we can design complex structure solutions, for example, like shells, plated structural elements, and complex steel joints. This can be used not only in design, but in case of virtual experiments and in research and development projects. And we can say that this new feature is one of the new features that raise the axis on a highest level, almost on academic level. As an example, I collected some guidelines from Eurocode 3 for the suggestions or guidelines to select equivalent geometrical imperfections. As you can see, we have some guidelines for general rules, chapter 1, and we have some specific guidelines from chapter 5 and 6. As I told at the beginning, imperfection shapes can be created from elastic backlink mode shapes. Accordingly, we placed our new button on Backlink tab. As you can see, the arrow shows the place of the new button, and if we click on the button, a new window opens. In this window, we can see the collected backlink results, the backlink mode shapes, and the created imperfection shapes. We can assign one or several backlink modes to the selected imperfection shape, and we can give the result component for the scaling and the maximum amplitude. This is really important because the maximum amplitude is used, the absolute value of this amplitude is used to scale the maximum value of the selected backlink mode shape, and the sign of this amplitude is used to decide about the direction of the imperfection. The result component is used to select the maximum value of the mode shape. After we created the imperfection shapes, we can create load cases, imperfection load cases, and load groups. In the load cases, we can select the imperfection shapes applied in the selected load case. We decided to use load cases and load groups to control imperfections because it is very practical. These imperfections are combined and varied together with conventional loads, for example, self-weight and snow loads. And the use of load combinations makes very easy to consider these imperfections. The load combinations, including the imperfections and conventional loads, can be considered in nonlinear, static, and dynamic simulations. We have to perform the nonlinear analysis for the selected load combinations. It is important that geometric nonlinearity need to be considered. We had already an existing feature, namely a load case from global imperfections. And now I would like to give you a short comparison between the existing and the new feature. In case of the existing feature, we could generate and create only global imperfections. And these global imperfections is used in a linear shape. With this new feature, we can create not only global but local imperfections, and it uses not a linear or nonlinear functions to create the form. It uses the elastic backlink mode shapes, and we can combine not several backlink mode shapes in a certain imperfection shape. I prepared today, I prepared an example. This is a very trendy structure, structural form. It's a free-form, three-dimensional diagonal grid. We can find several examples in our capital as well. And my example can be seen on the left. Here you can see the example structure in Axis. The structure has 40 meter, has length 40 meters and width 20 meters. The height of the structure, the highest point, is approximately 12.6 meters. According to the elements and boundary conditions, I applied beam elements with 6 degrees of freedoms at each end. I attached pipe and EGB sections to the beams. Tube sections were used to model the grid, and EGB sections were used to model the beams and columns at the entrance and around the skylight. I considered pinned supports as boundary conditions that they restrict only translational movements. According to the material, I selected isotropic steel material. A similar structure has various loading conditions. However, in this example, I considered only some of them. I considered and modeled dead loads and snow load only. In case of the dead loads, I considered the self-weight of the steel structure, the weight of the glass panels, and some load for possible installations. In case of variable loads, I applied snow load. The structure weight was modeled by self-weight option and concentrated loads. The weight of glass panels and installation were modeled with the help of distributed load. The snow load was also modeled with a distributed load, but I consider snow load only at the top of the roof. In order to create the imperfection shapes, first we have to run backlink analysis to obtain backlink mode shapes. In this example, I calculated 20 modes. The structure is sensitive for second-order effects and deformations if critical load amplifier is lower or equal to 10. As you can see, we have several modes where the critical load amplifier is small. So definitely we have to use nonlinear static analysis. I will show you some modes. For example, the first backlink mode is about the backlink of the column of the entrance at the entrance. And similarly, the third mode is also a backlink shape for the column, but not the right, but the left column at the entrance. The fourth, fifth, and sixth modes are global backlink modes of the grid. As you can see, the sixth mode is affecting much bigger area from the grid. So it can be said that sixth mode is more global than fourth and fifth mode. And the eighth mode is a global backlink mode for the grid as well, including the beams around the skylight. In this example, to demonstrate the possibilities in the new module, I selected only 3 modes. I selected the first mode, that is a backlink mode for the right column at the entrance. I selected the sixth mode as a global backlink mode for the grid. And I selected the eighth mode because the backlink of the beams around the skylight are also included. Of course, in the real situations, more backlink shapes need to be covered, but in this example, I used only these 3 backlink modes. I clicked on our new button to open the window of imperfection shapes. And as you can see, I see all the backlink results on the left. Clicking on the button showing a positive sign, we can add new imperfection shapes by writing their names. I created 2, imperfection 1 and imperfection 2. I will assign the first and sixth mode to imperfection 1. And I am going to assign the first and eighth mode to imperfection 2. I will not combine sixth and eighth modes because they have an intersection on the grid where both affect some parts, and for this reason they could weaken or strengthen each other, but it is not sure. After creating the imperfection shapes and assigning the mode shapes, we have to select the component according to we would like to give the maximum amplitude. In case of a vertical column, we may select a horizontal displacement, but I have a 3-dimensional freeform structure, thus I selected the resultant displacement. This maximum amplitude can be calculated according to the design code, as I showed you in the presentation. For this local, almost can be said that it is a local backlink shape for the column. 27 millimeters can be calculated. For the grid, 30 millimeters. I considered the guidelines of Eurocode 3 Part 1 in this case. After we created the imperfection shapes, we can select them from the drop-down list, and Axis will show you the shape. Similarly to other result components, so every possible rendering and visualization options can be used. As you can see, the second imperfection shape is a combination of the shape for the column and the skylight beams. After we created the imperfection shapes, we have to go back to the loads tab to create the load cases, as I did earlier, and including, as you can see here in load group window, and now creating the load combinations, including the imperfections. As you can see, I created for both imperfection shapes 2 load combinations where I applied a positive and a negative value respectively, because before the calculation, I don't know that which direction will be critical. So I consider the imperfection with both positive and negative signs. If you select the load case from the drop-down list, Axis will show you the backlink, the imperfection shapes, not only on backlink shape, but also on this tab. Not only the backlink tab, but also in case of this tab. After we created the load cases, the load combinations, we can go further to static tab and run nonlinear static analysis. Here, we need to check the load combinations we would like to consider in the analysis and run the nonlinear static analysis. Axis will consider the imperfect shape as an initial shape of the model. And this way, all of the second-order effects coming from the imperfections will be included in the results. It is very important to note that if you change the model, for example, you change the material, you change the loading conditions, or you change for example, the cross sections, you have to revise the imperfection shapes, because the backlink mode shapes can be varied. For example, I had 6 mode as a global mode for the grid, but I had the first mode for a local backlink of the column. But if I strengthen the cross section of the column, it can happen that the first mode will be a global backlink mode for the grid, and the 6th mode will be the backlink of the column. So every changing the model, imperfection shapes need to be revised.